carboxylic acids and esters, and we've already had a look from alcohols. We know that we can make carboxylic acids. I'll just briefly remind you of that. The equation, in fact, I'll write it in the condensed form. So from ethanol, under oxidative conditions, so either leaving out in oxygen, some bacteria might help that process along, or you can add a specialist oxidizing agents that chemists have. What will happen is that ethanol will be oxidized to a carboxylic acid. So we drew it in the fully displayed formula before, like this, but I want you to see the condensed form is like this. COOH is how we write this in shorthand. So CH3, you always write carbon first, and then the things that are around it afterwards. So CH3, then a carbon with 2 oxygens and a hydrogen coming off it as the carboxylic acid, and the byproduct was water. Okay, so we know that's a way of making carboxylic acids, but you need to know a bit about carboxylic acids, some of which you already know. So first of all, they're weak acids. This is a good chance to practice with you a little bit of knowledge from the acids topic. And I've seen, it's a ridiculously easy question, but if you think about it, but it's often one that people don't get right because they don't get what the question's asking. But what is a weak acid? For 2 marks, you've got to say what an acid is for 1 mark and what weak means for a 2nd mark. So weak acids, just to remind you of this, are things that release H+. Hopefully you're comfortable that that's what an acid is, but how many of you would have written it in an exam? So in other words, somehow it releases H+, just like HCl releases H+. But with weak acids, of course, you only get partial dissociation of the acid. So, and so what that looks like. So that would be a definition of a weak acid. So partial dissociation of the acid to release H+, something like that. But what you've got then is something like this going on. You okay? What's up? So you've got partial dissociation of the acid. You could write this one of 2 ways. I'm going to write it both of them so that it's familiar to you. You could simply write it as an equilibrium symbol like that, showing that the reaction is reversible, going in both directions, and that the H+ is lost. But because it's a weak acid, it's lying very much to the left-hand side. So the pH of these is typically around sort of 4 to 6, that kind of range. Much, much lower hydrogen ion concentrations because it's only partially dissociated. Sometimes it's written like this as well. This is kind of more of an IB point, I suppose, but you might as well see that this really happens with another substance like water. There's the H fallen off, but it's ended up sitting on water. There you go, like that. So that's what acids do. That's what carboxylic acids do. Now the thing about weak acids as opposed to strong acids, they do the same thing as strong acids but slower. That's it. They do exactly the same things but slower. So for example, they will react with bases. And I'll give you an example of that. So if I took reactions of carboxylic acids. So they will react with a base, and the bases you've learned are sodium, or metal oxides, metal hydroxides, metal carbonates. The interesting, I suppose, one of all of those is the reaction with metal carbonates, because you can actually see what's going on. You take any acid and react it with any carbonate, you'll always get 3 things: salt, water, and something that you can see. So talk to each other. What's the thing that you can see when you react an acid with a carbonate? Right, so you're all saying that you're going to get a salt formed, which is CH3COO. I've drawn it to show that it's an ionic bond there, a bit like we did before, but sodium carbonate, sodium ethanoate, that's the salt. The ethanoate is just the thing we say, you know how like for hydrochloric acid we get chloride, nitric acid we get nitrate, sulfuric acid we get sulfate, ethanoic acid we get ethanoate. It's the same idea. And you get water, and as you said, you get something fizzing, and that fizzing is carbon dioxide, and you'll see that, and you're expected to. If you see if you see a question, what would you observe if? This is what you would see. And this equation's not balanced, so you need to balance it by doing that, and you'd be expected to be able to work that out yourselves in the exam. It's all due to the fact you've got 2 sodiums in sodium carbonate there, so you need to balance it out. This is what you would see. Evidence. Okay, so they react with acids, but you do that with hydrochloric acid, and you do it with ethanoic acid. So the key thing is that it's much slower for ethanoic acid than for hydrochloric acid of the same concentration. This idea applies equally to the reaction, say, with sodium. You chuck sodium into an acid. Oh no, that'd be crazy. It would explode, and you need to know that. If you chuck magnesium into an acid, it will react. You do the old squeaky pop test in year 8 or whatever. You do that by chucking magnesium into hydrochloric acid. You could do the same thing, magnesium and ethanoic acid. It would work, but it would take a long time. I might as well write that down, given I've said it. It's a very slow reaction. Magnesium forms a 2+ ion, and ethanoates a 1- ion. So we need 2 ethanoates for every 1 magnesium. Which means we need 2 ethanoic acids, and you get H2. Remember the old metal plus acid gives you salt plus hydrogen, MASH. But I've written the A and the M the wrong way around. So metal plus acid, salt plus hydrogen, MASH. Stuff that you know, stuff that you learnt a long time ago, but maybe you don't know you need to know. Right. So in other words, the key message here is that ethanoic acid, carboxylic acids do the same as strong acids, only slower. But there's one other thing that they do that we need to know as well, and that's what I'm going to go on to in a sec. I'm ready. Please make sure. Oh, I see. You've written H like that. Did everyone get that? There you go. A sec. There. Now that equation there, I'm not asking you necessarily to go away and learn that, but it's the sort of thing that you probably could work out on the fly in an exam if you're really into this wonderful subject. But the key thing you absolutely must know is they react like normal acids, react with bases, react with carbonates, react with reactive metals, all of that stuff that you should know. Right. The other thing that they can do, this is new to you, and I'll have a little bit of fun with it, probably not on video though. So esters. So what I'm going to do is going to write down the thing that you need to know, and then we're going to talk about it a bit afterwards. So you can write up and copy as we go. So if you take a carboxylic acid, and again I'm going to use ethanoic acid. It doesn't matter what carboxylic acid it is, but you take ethanoic acid and react it with an alcohol, and I'm deliberately drawing the alcohol this way to help you to see what's going on. I'm going to choose ethanol as my alcohol. What you get is an ester. And because I've run out of space on my page, I'm going to draw it below. Hopefully you can see. Can I do that yet? Can I come off that other page? red pen. There's that red pen. So what's going on here, this is what we call, and you expected to know this, so I'm going to write it in red, underline it, put a star next to it. This is a really important type of reaction called a condensation reaction. You've probably heard of condensation reactions, or the word condensation, sorry. You've probably heard the word condensation used. We talk about condensation on the windows, right? What is condensation on your windows if you car, if it's cold? What is that? It's not evaporation, it is actually just water. It's water that's water vapor in the air that's hit something that's really cold, and it's condensed, it's turned into water, liquid water. So if you generate water from a chemical reaction, we also call that condensation. So condensation, if you just make a note, formation of water in a reaction. It can be other things, it can actually be any small molecule, but really it started off as a word by being the formation of water from a chemical reaction. So if we look at those molecules, how on earth can water be formed from them? And if you look, there's an OH over here, there's an H over here, that end up being water. Right, so I'll write that in red. Those molecules, those atoms, sorry, in the carboxylic acid and the alcohol turn into water. Now that means this carbon is no longer attached to this oxygen, and it means that this oxygen is no longer attached to this hydrogen. And what's happened there is this oxygen has joined up with this carbon and spat out the water, essentially. We'll come to talk in a lesson after the mocks about something called condensation polymerization, which is a very, very sort of complicated idea that they've shoved into the GCSE, which I'm not a massive fan of it being in there. But one thing it's important for you to know that all biological molecules that are polymers come through a process called condensation. All the amino acids clip together to make protein through condensation reactions. Starch is formed from sugar molecules clipped together through condensation reactions. DNA comes from nucleotides that clip together through condensation reactions. So biology is a really important process. So that is an ester molecule, and you always get water as well. 2 marks for drawing that. And I've written it that way. I'm also going to write it in the other way as well, so you can see that it can be written in the shorthand way. So COOH plus CH3 CH2OH. The ester, the first bit of it's the same, but then we've got to attach it to the CH2, CH3 and H2O. This ester, by the way, is called ethyl. Ethanoate. Lots going on here, whereas the complexity is going up a little notch. And esters have got all sorts of uses, particularly in perfumes, because they have sweet and fruity smells. Okay, and that reaction you're expected to know requires an acid catalyst. And really I should have put on there that it's a reaction that's reversible, it's an equilibrium reaction like that. So can you do change that to a double-headed arrow? Okay. That's about it in terms of facts, but I've got a bit of a fun way to help you remember that I'm not going to record.